Okay, so here we are. We're going to go ahead and start some other things, in programming and stuff. Let me just make this a little bit bigger again. Oops. And I'm not going to be using gedit anymore. I'm going to be using my kind of favorite text editor, simply because it's faster, but you can still keep using, gedit. If you want to learn how to use this one, that's fine. I will teach that too if there's a request. So, let me make this bigger. We went through the specific. Let's change this because. So, last time we went through the specific kind of ways that this program actually runs, like what's happening at each step, what this main function kind of is, what we're returning. We're returning a 0, what printf does, why we need this, \n. So now what we're going to do is we're going to say, well, I know what my program does, but usually programs aren't this simple. So what will happen is that sometime down the line you might come back to your code that you wrote a while ago, and you'll be wondering, well, what does all this do? And what you can do is you can read through your entire program and try to figure out what it does. The other thing is that you can have documentation. So documentation is stuff that is meant for you and other programmers to read, and that should better help you understand what the program does. So usually in documentation, people put things like, you'll notice that it appears, when I put in documentation, it will be very, grayed out, and that indicates that the compiler doesn't read it. So if you say, author, or Gupta Shark. You can say date created, I think it's June 10th, 2015. You can say purpose of the program, and it's just like print hello, put this in quotes. So basically these are all comments, right? And the way we know that they're comments are because there is a double slash at the beginning of the line that these comments are on. What this tells the compiler is that, hey, whatever is after these slashes, it's not meant for you to read. It's meant for other programmers. So don't try to interpret it, just skip the line. And this is fine. The compiler will understand and everything will happen. This is one way to do a comment, and you can actually do this at the end of a line like this as well. So, prints hello world. So you can notice that even though it's on the same line as something that is a valid C program, the syntax highlighting tells us this is still going to be read by the compiler and this part is not going to be read, simply because it's now a comment. Okay, so comments can start anywhere on the line. Now sometimes you want to do a lot of commenting. For instance, if you're going to be making headers for your files, copyright, blah 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 blah, and then names of other team members and etc., you might want a multi-line comment. You don't want to always put in these slashes at the very beginning. So what you can do is do multi-line comment. So this here is a slash and then a star. As you can notice, it grays out the entire program because the other, the ending star slash isn't there. If I put it here, star and then slash, C recognizes that, this is the beginning of the comment and this is the end of the comment. Okay? So if you ever want to nest, not really nest, if you want to do multi-line comments, this is how you do it. Also, there's no such thing as nested commenting. For instance, don't do this. It's kind of stupid. Obviously you can, but there's no real point unless you're trying to work out with test cases or figure out what's wrong with your code. And then this was already there originally. So the other thing is that you can't nest comments. For instance, this is a comment, and say over here I decided that I'm going to nest this comment by doing this. What the heck? Okay, you do slash star, and then you do star slash. As you can see, it doesn't like this, simply because it's noticing that there's this weird sort of formation that would be the start of another comment, but we haven't seen the end of the comment for this starting, comment yet. So it says, warning, this is not good syntax. And then here, this actually closes off this comment starter, not this one, because this is still inside the comment, okay? The compiler doesn't notice it, it treats it as a comment. And then this over here is left with no beginning sort of comment. In fact, it's just there by itself, and the compiler is not going to be happy with you. It's just going to throw an error, pretty sure. So don't nest comments, okay? Just use either a line comment or a multi-line comment for whatever you need, okay? So we don't need these anymore, and we don't need that either. So what we have is this one comment that just lets us know what the program's doing, okay? And you can check it, that the program will still run, gcc hello.c, everything went fine, right? Nothing changes. Okay, so now that we know how to comment our code and have good documentation, we should start doing things with the program. I mean, that's what programming is about, right? So, what we're going to learn about are the different types of variables that you can have in C. Basically, if you're going to be doing things with data, there's different kinds of data. For instance, you can have an integer, and that is denoted as int. You probably saw this over here, right? So an int, and then we have to declare the type of, we already declared the type of the variable as an integer. We have to say, well, what is the variable's name? Usually variables are like x in mathematics, but in computer science, we want to give descriptive names, okay? So let's say that we're trying to solve a particular problem, okay? Find the area, let's say the volume of a box with given dimensions. Alright, dimensions. So we can say, well, the length, right? We can say that there's going to be a width. We can say that there's going to be a height, right? Because a box with these dimensions will have these kinds of things. So long as we assume it's a rectangular prism box and not some kind of, weird box. So well, what did I just do here? These are all declarations. I said, hey, I want a length, I want a variable of type integer, so it will hold an integer, and it should be called length, okay? And then now if I do volume, I can actually say that this is equal to length times width times height, and then make sure I put the semicolon at the end, okay? Because these are all statements, and we need to put semicolons at the end of statements. So, these are declarations. I've declared the variable length, okay? Whenever you're going to be doing anything with variables, there's two steps. There's the declaration, and then there's the initialization. Init. Yeah, it's not a fun word to spell. Anyways, so what we've done is we've declared the variables, but they don't hold anything. It's not like we're really trying to solve for x or something. We want to give these variables values. So what you can do is you can say equals a number 5, okay? And we can do the same thing here, equals 4, and you can say equals, 6, okay? And this is usually what people do. When they declare a variable, they'll initialize it at the same time, okay? Now, what you didn't notice is that this equal sign isn't normally, what you would think in terms of mathematics, that equals is, oh, this is equal. But you cannot initialize variables the other way around. Like, you can't go 5 equals length, okay? And that's simply because the idea is that you are taking this 5, this value, and putting it into length, okay? You can almost imagine it as going like this. We're taking 5 and putting it into the variable length. So the variable length now holds the value 5. Okay, but the syntax is this. Okay, so here the compiler would think that you're trying to take the value of length and put it into 5. Well, 5 isn't something that can hold a value, right? It's literally the value. So this would not make sense. Okay, you're always going to be putting values into variables. Now once you have a value into a variable, you can use other variables to put values into other variables. For instance, that's what we've done here. We've declared volume, and then we've said, okay, well that should equal length times width times height. And these are all going into volume. Okay? And then you can have this as well. I mean, obviously this is not the correct answer to this problem, but we know that we can do this in the sense of now the value that length holds, which is 5, is going to be the value that volume holds. Okay? So I'm just going to change this back to that. Okay? Now that we've found, well, we've used some math, right? This time the star is obviously multiplication. Now that we've used some math to put the correct answer to find the volume of the box with these given dimensions, we have to be able to check, like, did we actually get the right value into volume? And what we need to do is we need to print the value that volume has out into the screen. So this is going to involve modifying this printf statement. So I'm just going to get rid of this, and we're going to say the volume of the box is, and I'm going to have to use another printf here. Okay, %d new line volume. Okay, so let's analyze what's happening here. The first printf doesn't do anything except for just print out the volume of this box is. It's just telling me, you know, what the program is doing. And what I mean by that is that obviously if I didn't have this, it would just print out a number. Okay, so it's nice to let people know who are looking at your program, like what, you know, you're printing out. Like, what is this value that I'm printing out? It's the volume of a box. Okay, obviously you don't need to have this, but it's nice practice when you're starting coding. If you're just working on something, you don't need to have it. Okay, so and when I say working on something, I mean like a scrap piece of code that you understand fully what is being printed out. So here we need to look at this a little bit further because there's some new syntax here that we haven't seen before. Okay, so first off, we actually do need to put in the quotes. Okay, now this %d is kind of like this \n. \n is that special type of character that we saw before that just indicated this is not a, you know, an n, it's a new line, you know, go to the next line so that the command prompt doesn't print out on the same line. This %d tells us that there's going to be an integer here. I'm not sure what, but you should look after this comma to find out what that integer should be. Okay? So what C will do is it will say, okay, well, this %d, that's for an integer. There's a volume here. Volume is an integer because we declared it to be of type integer. And we're going to print out what it is. Okay? So let's run this program. I'm going to save it and GCC. Okay, and then if we run it, we get the volume of the box is 120, which is what we'd expect, right? I mean, if we quickly look at our Python calculator and we do 5 times 6, that is actually 120. Okay. So what we have here is basically we now know that we have one type of data that we can work with, integers. We declare the type of the variable, and when we're declaring a variable, we have to declare its type. If instead I just did this and didn't, you know, tell the compiler, hey, it's a type of integer, the compiler is going to complain that I haven't declared the variable. Let me just clear the screen. It's going to say, in function main, the length is undeclared. Use first in this function. Note for each, blah, 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 blah. So, you know, it's complaining that we haven't declared it. The other thing, if we don't initialize it, the the compiler may or may not complain. And what if I do this? Okay, so let me explain a few things. GCC hello.c. It didn't complain simply because when you don't initialize a variable, the compiler might actually just initialize it for you. So for instance here, it initialized it to 0 because we noticed that 0 times 4 times 6 is going to be 0, right? There's no other number that length can be. But if we do gcc-wall hello.c, let me clear the screen. It says in function main, the length is uninitialized in this function. So the point is that it's a very good idea to declare and initialize on the same line, simply because it avoids the problem of having something undeclared and then forgetting to initialize it later. Okay? Because what you can do is you can say, well, I'm going to declare this integer length, and I'm going to declare this integer width, I'm going to declare this integer height, and later I'm going to say, well, length equals 5. I kind of forget what I put in there, but anyways, width equals 4, and height equals 6. So, as you can notice, I've declared these over here, and then I've initialized these over here. So, if I gcc-wall this, everything's fine, okay? It doesn't complain that the variable is uninitialized because I've initialized it later. The thing is that you don't want to forget to uninitialize it, because sometimes there will be garbage values in here. And we'll see in a later situation when we might have garbage values. Usually in the main function, these are set to 0 if you forget to initialize them. But the idea is that if you're declaring a variable, you might as well initialize it so that you don't forget later. Okay? So just do this. It's good practice. Equals 6. Also, it makes your code a lot easier to read. At least I think so anyway. If anything's conveniently on one, line, both the declaration and the initialization. Also, I feel like I should explain what gcc-wall is. So, -wall basically says be very thorough when you're checking for errors inside of this program. And when we didn't do -wall, and whoops, when we had something like this, GCC was fine, but if we do gcc-wall, wall checked very thoroughly for these kinds of things, and it lets us know this is a warning that it's uninitialized. So whenever you're compiling, you actually should try to compile with -wall, simply because it's safer, okay? And when you do that, everything you catch little bugs, and it actually it helps you figure out small errors better, okay? So if you're ever stuck, try compiling with -wall, and it should help, alright? So let's go back to this. That's pretty much everything, actually. For a recap, we at the beginning learned that we can make comments, and that we use those comments to let other programmers know what we're trying to say. And then over here, we have different kinds of variables. Actually, we have just one kind of variable of type integer. We will explore different types of variables in the future, but we wrote a simple program to solve a specific problem, which was to figure out the volume of a box. Okay. In the future, we're going to expand on this by asking the user for input on what is the length, what is the width, what is the height, and then printing out the volume of that box. Okay? So I will hopefully see you soon.